Start today, have a go at these two questions. If you're a bit unsure, then try the first one and then watch my explanation before you move on to the second one. Key thing here is that we need to use this, well, we've got an angle side pair here, and we're trying to find this side in this angle side pair, so it's going to be the sine rule. That is going to be the way we have to deal with it. It's not 90 degrees, so we can't use SOHCAHTOA, normal right angle trigonometry. Instead, we're going to use A over sine A equals B over sine B. We've also got this equals C over sine C, but technically we don't need that here. We're just going to use the first two. So we've got the A and the A labelled. We just need this part, and then we can use this here and just simply substitute in. So it's going to be A over sine 54 equals 3 over sine 27. And what we can do is multiply through by sine 54. So it's A equals 3 sine 54 over sine 27. Sorry, the 2 disappeared from there. And that can be substituted in to a calculator. Just for info, by the way, if you have already got it, the answer is going to be 5.346. And this is one I did earlier here. 3, you can just see I put it in. And you might round that to, so let me just write it down, 5.346. So you might round that to 5.35. Okay, the main thing is the method. How about the second one? Well, here we have an angle side pair, but we're being asked for YZ, and we don't have this angle here. So the first thing we're going to have to do is work out this angle here. 95 plus 40 is 135. So 135, what do I add on to get 180? It's going to be 45 degrees here. And now I can see I've got another angle side pair, but I've got to do that in that first step before I can use the sine rule. I've got Y, X, and Z. I'm just gonna, I'm gonna get rid of them in a second and label it like in more traditional ways, A, B, C. So this is A, this is capital A, and that's the one I'm trying to find. And then my other pair is, I'm going to call this one B and this one capital B. I don't need to label the other one. And then I'm ready. I just do the same as before. So yeah, we get 45. We can then write down that A over sine 45 equals 4 over sine 40, multiply through by sine 45. So it's going to be YZ or A in our case is equal to 4 sine 45 over sine 40. If you can do that, you're in a good place. You've understood the sine rule, calculating sides. Well, we're not going to stop there. What happens if we have angle pair side and another side, but we want to work out the angle? That's what we're going to be looking at today. But we're going to need to do a little bit before that, because at the moment the formula is not that useful for finding angles because it's on the denominator. So let's take a look. Let's consider these fractions. We've got 4 over 8 equals 3 over 6 equals 12 over 24. They are equivalent fractions. If we flip them around, basically replace, just basically put the 4 on the bottom and the 8 on the top, are they still equivalent? Are they going to become 8 over 4, 6 over 3, 24 over 12? And the equal signs imply yes, they are. I've shown you they are. The answer is yes. You can flip it around and it's still the same. They're still equal. So if we have our sine rule from previous and we flip it around, then it is still going to be all okay. And this is the angle version of the sine rule. You could use this one. It's just the thing you're trying to find is going to be on the bottom. Whereas now if we just put it on the top and put the lengths on the bottom, it's going to be easier. Again, learn this one, just basically learn the first one and that you can flip it around. If you're still a little bit unconvinced, then don't forget last lesson I derived the sine rule and I got to here and then I set them equal to one another. B sine A equals A sine B. But this time instead of dividing through by the sides, by the the angles I can divide through by the sides. And you can see if I divide through by A and divide through by B, then I'm again going to get this formula. So just let me say once again, like is that you could use this one, but it's going to be better if you're finding angles to use this one on the right. Here goes then. Here's an example. If you're feeling confident, then go for it and have a go. Otherwise, I'm going to go through this one. Find the size of angle R. Right, well, we've got an angle side pair here, and we've got an angle side pair just with the angle missing, so it's going to be the sine rule, of course. I'm going to label this, I think I'll label this little a, and then this will be capital A. It's absolutely fine to relabel as I like, instead of using Q, R, and P. And then I'll call R, I'll make that capital B, and this B here. So now I can write down my new version of the sine rule. It's going to be that sine B over B equals sine capital A over lowercase a. Substitute them in. Sine B is the thing that's missing. It's going to be sine B over 4 equals sine 75 over 9. And we're in a similar place to previously now. We've got that sine B, we can multiply through by 4, just like last lesson we times through by sine of whatever it was, we can times through by 4. I'm going to put it before the sine 75, that's good practice, and then we're dividing through by 9. Probably work out what that is, but that is our answer for sine B. Oops. So sine B is this third here. I might just write it as a decimal, 0.4293. Now, if I want what B is, I have to do what we do when we're trying to work out angles in trigonometry. I do the opposite of sine to get back. It's going to be the inverse sine of 0.4293. Just make sure you use the full thing, you don't round it. Okay, you don't want to, if you introduce rounding errors, then they can build up and your final answer won't be correct. So we can do shift, sine, and then the answer button will use that exact answer that I just had. 25.423 or 25.4 degrees. Brilliant. So we can now use the sine rule. We can calculate sides. We can also calculate angles. Note if we did do it, I think it does it. Yeah, it does it same here. If we did do it I just want to talk about like why we should use this approach rather than the other approach from last lesson, because then it would be A, or it would be B over sine B equals A over sine A. Like it will still work, and then it's going to be 4 over sine B equals 9 over sine 75. But then you're going to have to times through by sine B. So 4 equals 9 sine B over sine 75. Then we're going to have to times through by sine 75 and divide through by 9. There's just these extra steps, like, you know, you can do it, like it will work. There's no major issue with it, but there's just more, it's just more complicated. So best to use this alternative form. Okay, you have a go at this one here. Right, and actually the extension is to work out the other angle, A. How could you do that? Or if you were asked to work out A to start with, what would you do? Well, you would work out B to start with, and then you could work out the missing angle. Here's the answer. I'm going to go through it. So they've labelled it, and it's, you know, it's okay. So I'll stick with their labelling. This is going to be little c, and this is going to be little b. We're going to have that sine b over little b, which is 4.7, equals sine 63 over 5.5. Multiply 3 by 4.7. Okay, 0.761. Might want to write a few more figures down, and then b is going to be inverse sine of that. Answer button comes in really useful, 49.58. And as you saw it rounds to this to 3 significant figures. You don't even need to necessarily write all this down. It is a good idea to write the answer down before you round it to 9.588. And if we wanted to work out A, like to start with or afterwards, then we would just do A equals 180 minus 63 minus 49.588. And then we can just put that in our calculator. Again, answer button comes in useful, 67.41 or 67.4. Hopefully you're happy with that. We've looked at using the sine rule to calculate sides, and now today to calculate angles. Of course, you could need it for both, and I'll give you some questions on that in a minute. The next time we'll be looking at what happens if you don't have an angle pair. Maybe you've got some other sort of situation, but it's enough to work out other sides. And we'll see that, yeah, we're not finished with non-right angled triangle. There is more to it. Well done on your efforts. Keep going with this topic. It's really powerful. It extends right angled trigonometry, and then it's allowing you basically, if you just know 3 things in a triangle, as long as you've got an angle side pair, then you can work out all the other sides and angles. Brilliant. Have a go at these 6 questions to practice the sine rule. Just going to flick to the answers. This is what you should get. And then after that, try this exercise 86 star, where it's basically combining the last 2 lessons. You have to find the sides and the angles in different situations, showing the power of this method. Here are the answers to those. Next, exercise 91 is revision. Have a go at this one. You might not have covered this topic before, to be fair, in which case really important to try a question like this where you've got angles and sides in a 3-dimensional shape. I'll go through this one in a minute, but those are the answers. And then finally, good challenge question here. What happens when I've got 2 adjoining triangles and I'm trying to work out some lengths and angles? Give this one a go. Here are the answers to this one. All right, I'm not going to go through 86 star, but I am going to go through this question here. So I can label this as, by the way, it's essentially trigonometry. Part C becomes 3D trigonometry. We just need to be a bit careful with that one. This is 400 and this one's 100. So the angle that CD makes with ADF, that's actually just this angle here. It's the angle that it makes with the base. And this is DE is part of the base. So once we've got that, it's not quite so bad because we can just draw the triangle by itself. 100, 300. We have a right angle. We're working out this angle here, which I'll call X. So it's going to be tan X, because I've got the opposite and the adjacent. is 100 over 300, which, by the way, just cancels down to a third. So we can then do the inverse of the inverse tan of 1/3, which gives us 18.43. Okay, I'm not going to write all my working down there. 18.4 degrees. For B, we're finding AE. That is that length there. And actually, you've got to recognize that because the base is a rectangle, it doesn't look like it, in some ways, because we're drawing it in 3 dimensions, but that angle there is a right angle. So that is D, that is A, and that is E. 400, 300. We're going to use Pythagoras' theorem here. 300 squared plus 400 squared equals AE squared. So AE is the square root, and that equals 500. You put it into a calculator. Lastly, the real 3D part is to work out the angle that CA makes with ADEF. And CA is, okay, so I'm going to need to draw another line. But the previous work that I've done is going to help. Because now, where's my triangle? I've got this blue triangle here. And I've got a right angle at the bottom because the base is meeting CE. So the height is 100, the base is 500. I'm being asked for this angle here. So again, it's going to be tan. Tan x is now the opposite over the adjacent. So it's going to be 100 over 500, or 1/5. So x is going to be inverse tan of 1/5. Good question. 11.3. And I'm going to go through this very last one. Right, I can label things, but I can relabel them as I go along. That's something to say at the start. Work out the length of AC. So I think I'll call this little b for the moment because it's opposite that angle. I can kind of ignore this. Wait, I need to think about what I'm going to use actually. So yeah, actually, I made a mistake. Okay, got it. So I'm actually going to use the bottom triangle to start with because I do have an angle side pair. That's the only angle side pair I have here. So I'll keep that as capital A. This will be little a. And maybe I made it confusing by calling it little b. Okay, I can actually stick to calling it D, and then this will be little d, and I can just write the sine rule down in terms of D. That's okay. So it's going to be D over sine D, because there's nothing special about the letters, equals A over sine A. That means D, which is this length AC I'm interested in, over sine 67 is equal to 6.7 over sine 33. So D is 6.7 times sine 67 over sine 33, which I'm hoping will be 11.3. Okay, 11.3237. For part B, I'll do this one up here. So I've now got, I can now even write that on. I'm not gonna round it though. I'm gonna write down 11.3237. I'm now being asked for the size of angle BAC. BAC, that is this one here that I'm interested in. So now I can see I've got an angle side pair in this top triangle. I can kind of eliminate the bottom triangle, and I've got the side part of the angle side pair over here. In this case, I'm gonna call this, what should I call? I'll call this angle A, and now this is little a, and I'm working out the angle, so it's going to be sine capital A over 7.1. That's my first angle side pair, equals sine 95 over 11.3237. Notice for the side I've used this version of the sine rule. For the angle I've used this version. I just can swap between them really quickly. So sine A is going to times through by 7.1. We're nearly there. And yes, you could get this sort of question in an exam. You get all sorts of, often it's got to be said, the exam questions are probably more likely to be like this than just your standard one. You get all sorts. Okay, I didn't save it as the answer button, but I've put enough digits there. That's going to be enough. So 0.624. So A is going to be the inverse sine of that. Which gives us 38.65. Or 38.7 degrees. Well done if you got that. If not, I hope you're okay with that now. Well done overall.